An allele that is lethal in its homozygote has a frequency of 0.05. What mutation rate would be necessary to maintain this allele in mutation-selection balance? So, whenever we hear the word mutation-selection balance, we're going to just think of this equation. This time, it's asking us, instead of solving for S, we're solving for M. So we can just use stoichiometry to just kind of exchange the values. So we want to get rid of, we want M by itself. These would cancel. And we'd bring over here. And then just kind of rewrite that so it looks a little more pretty. Our equation would look like this. So what we know is our frequency. So we're solving for mutation rate, and we're just going to assume the selection is 1, 0, 5 squared. So in the last one, I kind of showed you the trick with where you can count the zeros and then 1, 2, and then it'd be 1, 2. So it would give you 4 zeros. In this case, you can't do that with this one because 5 is actually, it's a little bit too big. I would really only use that trick I did in my last video when you have 1 in your place, because it's such a small value, it's not very likely to change. But with 5, and you're timesing it by itself, it's pretty likely to change. So in this case, I would just do this. Kind of the long, boring way of doing it. But this would give me 5 times 5 is 25. But 5 goes here, 2 up there. 5 times 0 is 0, 2. And then just 0. And then these are actually all just 0. So like you can kind of, this part doesn't really matter, right? So you know that your answer is 25 something. What is still true is that you can look at these. So how many values are to the right of decimal place? You got 1 here, 2, 3, 4. So I'm just going to add some zeros prematurely. Start from here, right? 25. That number before this decimal place was still the same, right? Because the decimal place is here, but I have to move it 4 times because, again, there are 4 values to the right of the decimal place. 1, 2, 3, 4. 1, 2, 3, 4. Which would give you 0.025. Come back to our original problem, even though it's just times 1, just to kind of complete it. We, according to this problem, in the math, we would need a mutation rate of 0.0025 to maintain that allele in the mutation selection balance.